sorry, what? I didn't quite hear that.
This is like an exponential decay or growth problem.
Okay.
The initial size of a culture of bacteria is 1,000. After 1 hour, the bacteria count is 8,000. Find a function that models the population after T hours.
Okay. Population is equal to what?
It's like 1,000 times T.
Well, let's get the general equation. I think it's very helpful when you're doing math like this to always start with the general equation, which is for continuous exponential growth, the general equation is e to the kt, I think, isn't it? A sub 0, e to the kt.
I'm not sure.
Okay. Let's go with that. And then I'll show you why it's correct. A sub 0 is your initial starting amount. K is a constant that we don't know yet. We're going to have to solve for K. We don't have to solve for A sub 0 because they gave it to us. So we can say the population is equal to 1,000 times e to the kt. So that's a little more specific equation. And now they've given us a second piece of information that the population is 8,000 after 1 hour. So now I can say 8,000 equals 1,000 times e to the k times 1 hour. Now, notice I can solve for k. And once I solve for k, what do we have here? Let's solve for k. How do I solve this?
So you would natural log both sides, correct?
Not yet. Let's simplify.
1,000 over.
Yeah, that makes it a lot easier.
And then take the natural log.
Okay, so now we have the natural log of 8 equals k. So now we can write the exact equation that models this particular bacteria. And that is the population is going to be times e to the natural log of 8t. And we could convert that to a number if you want, but we don't need to. There's nothing wrong with this answer. This is probably the best answer. This is a more accurate answer to give than putting a number in there, because natural log of 8 is a irrational decimal. We're going to have to approximate it. Okay, and there's probably a part B to this question. Like, how much will the population be at the end of 5 hours? Or when will the population hit 10 million?
What's the population after 1.5 hours?
In 1.5 hours?
Yeah.
So, we just plug in 1.5 for t. Put that in your calculator, and you'll get an answer.
So, for the most part, do all exponential problems require a calculator to solve? We don't get a calculator on the test, at least it's happening.
Really?
Yeah, they don't allow a TI-84s.
So if they don't allow a calculator, this has to be your final answer.
Yeah, it probably isn't.
Yeah, because nobody knows the natural log of 8 without a calculator or a table.
Yeah.
That's e to some exponent equals 8.
Yeah, I'll probably just have to do that.
So I'm not sure what they want you to do. It may be that you'll have a test where half of it you'll be allowed to use a calculator and the other half you won't, or something. But you know how to get this with a calculator, right?
Yeah.
All right.
All right, so then the next part.
Let me ask you a question. When will the population be 20,000?
Well, the next one was 1,500 or 15,000.
Oh, when will the population be 15,000?
So, yeah.
Okay, so how do we solve that?
15,000 equals 1,000 e to the ln of t, ln a t.
And now we're solving for t.
Divide by 1,000, 15 equals e to the ln a t. Would you log again?
Now make sure you don't write that like that, because now we don't know if we're taking the natural log of 8t or the natural log of 8 times t. So always put parentheses around that just to be clear. Okay. Now how do you solve this?
Would you natural log both sides? Or would you log both sides?
You natural log both sides.
Natural, yeah.
Yeah, so when I take the natural log of that, I get that. What do I get when I take the natural log of that?
Do the natural logs cancel out?
Well, whenever you have the natural log of e to an exponent, the answer is the exponent.
So ln 15 equals ln 8. And then you divide the ln 15 over ln 8.
And that's your answer for t. That's when the population will be 15,000. And if we think about that, that number, I don't know what that number is, but it's greater than 1. It must be greater than 2 even, because what we figured out that after 1.5 hours, it only grew to what? Didn't we do that first?
How many hours? 1.5? 1.5 hours.
Yeah, they were asking us how long it took to grow to 8,000. I think. But anyway,
yeah.
You can answer any question they ask as long as you know. Okay, you understand that problem pretty good, you think?
Yeah.
Feels like it. Okay, what else you got like that?
Let's try the half-life of Krypton 91 is 10 seconds. At time equal 0, a heavy canister contains 2 grams of this radioactive gas. Find a function that models the amount KR91.
At time equals 0, there's how much?
The half-life of Krypton 91 is 10 seconds. At time equals 0, a canister contains 3 grams.
How many grams? I don't get that number when you say it for some reason.
3.
3 grams, okay.
Yeah.
So we start out with 3 grams. And we know that because it's radioactive decay, that's the same as continuous decay. Just like continuous growth. In other words, what bacteria are doing is the same thing this is doing. It's just one is growing and the other is decaying. But you still use the same exponential equation. It's just k is going to be negative. Okay? So, what does it mean to say the half-life is 10 seconds? How can I use that information to write my equations?
Not.
Okay. How about the half-life is going to be when the original amount becomes half that amount. Well, we even know what the original amount is. It's 3 grams. So I'm looking for when y becomes equal to 1.5 grams.
Okay.
And we know that it becomes equal to 1.5 grams at 10 seconds, right?
Yeah.
So there's only one variable in that. That's k. So we can, So we can solve for K, and once we do, we will then have the new equation, y equals 3 times e to whatever K equals to times T. And that'll be our specific equation to this problem. So let's solve for K here just to make sure you can do it.
I don't know what 1.5 divided by 3 is.
It's half.
It's a half.
Uh-huh. 1.5 is half of 3. So 1.5 divided by 3 must be 1/2.
Oh, yeah, that makes sense.
Okay, so e to the k10. Now it's important to know that our t is going to be in seconds here, not in hours. So I don't put the units on there, but we know that it's going to be solved in seconds. Okay, so now if I take the natural log of both sides, logs of numbers between 0 and 1 are always negative. Doesn't matter if it's natural log or what, but go ahead and look up the natural log of 1/2.
It's negative 0.69.
So divided by 10, it's what?
Negative 0.069.
So there's K. So now let's rewrite the specific equation. Y equals 3e to the negative 0.069t. Now with this equation, you can tell how much of that stuff's going to be left at any point in time. Notice that as t goes to infinity, this goes to 0. In other words, eventually this stuff decays totally.
Yeah.
If t is long enough.
So it says how much remains after 1 minute and just plug 1 in for t, same as the one.
Uh-huh.
Alright. When will the amount remaining be reduced to 1 micro?
When will the amount be reduced to how much? 1 micro?
Yeah, 1 microgram.
So what equation?
1 microgram equals 10 to the negative 6.
10?
To the negative 6. This is the same problem.
I'm confused. I got lost. I thought the question was, at what point will there be 1 microgram instead of 3?
Yeah.
Okay, well, to solve that, I let y equal 1
Oh,
and use the rest of the equation. Now there's only one variable there that needs to be solved for, and that's t.
why is it y equals 1?
Because y is the total amount of that stuff at any point in time. Notice that at time 0, y is equal to 3. That's what you start out with, 3 micrograms. But as time starts clicking away, y starts going down. And in fact, at the end of 10 seconds, y has been reduced to 1.5, from 3 all the way to 1.5. So they're saying if it goes from 3 to 1.5 in 10 seconds, how long does it take to go to 1 microgram instead of 1.5?
But yeah, it says 1 microgram is 10 to the negative 6 grams. So when you put 10 to the
Oh, now I see what you're saying. I thought we were in the same units. So 3 was not micrograms?
No, 3 is grams.
3 was grams. Okay, so in other words, it's 1 times 10 to the negative 6?
Yeah.
Okay, so that's what we have to solve. So a microgram is a millionth of a gram. No wonder I was confused. I figured I just didn't hear the micro when you originally told me the 3. Okay. So you know how to solve these? We don't need to go through that?
Yeah, it's the same process. Use natural log.
Divide by 3 to get rid of that. Take the natural log of both sides. And when you take the natural log of e to any power, you get whatever that power was. So t is going to be equal to this number divided by minus 0.069. And there's your answer for how many seconds it will take to get to 1 microgram. I suspect quite a lot. I don't know what that number is, but I suspect it's a big number.
Okay. The next question. In earthquake measuring 6.4 on Richter scale, struck Japan. Earlier that year, another earthquake measuring 3.1 was in Pennsylvania. How many more times in specified? So there's an earthquake of 6.4 and then another one of 3.1. How many times bigger was the 6.4 than the 3.1?
Okay. Do you know how to do this?
Just divide 6.4 by 3.1.
No, the Richter scale is a logarithmic scale.
Oh, is it?
Uh-huh. So the difference between an earthquake magnitude 4 and an earthquake magnitude 5 is 10 times. 6 is 10 times more. So a 6 is 100 times more than that.
So then 6 is 1,000 times bigger.
Yeah.
So
Now the question is, how do we apply the decimals? I'm not sure I know exactly how to do that. I guess we could do, in other words, what we're saying is that if we had a 3 and a 6, I would divide the 2. No, I wouldn't. I would subtract the 2 and make that the exponent of 10. Right? In other words, a 6 would be 1,000 times bigger than a 3, and we would do it like that. So if we did the same thing here, we would take the difference of these two numbers, which is 3.3, and we would take 10 to the 3.3 power.
well, wouldn't 10 to the third be 10,000?
It'd be 1,000. It's the number of zeros that you have. So that's 10 to the third. So 10 to the 3.3, you're going to have to look that up in a calculator.
3.3 is 1,995.
So I think that's the answer. Do you have answers on these?
Yeah, I do. That's the right answer.
It is, okay. So that technique works fine. Just subtract the two numbers and raise 10 to that difference.
All right.
I could probably do it more eloquently using logs, but I guess we don't need to, as long as you know how to do those problems.
All right, so real quick, this is a invested savings account one.
Okay.
12,000 is invested, and its interest is 5.6% a year.
APR? Annual?
What's APR?
Annual
yeah.
percentage rate? Because there's various ways money can be, it can be
Yeah,
compounded yearly, it can be compounded daily, it can be compounded continuously, and you have different equations for each.
Yeah, it's yearly.
So this is yearly, okay.
Which one's annually, compounded?
That's yearly, that's annual,
Okay.
okay.
So isn't it like P equals 1.
Your initial amount
Hey.
times 1 plus your rate of interest
Over
to the t.
power.
This is the simplest equation, and it only applies to annual compounding.
For the other ones, you have to the power of Tn, right?
Right.
And plug in.
In other words, the second one, and this is less than a year, less than annual. In other words, either monthly or daily. That is a sub 0 times 1 plus r over the number of times per year it's compounded times t times the number of times a year it's compounded. So this equation, say it was compounded monthly. You would take the annual rate, divide it by 12, and raise it to the t times 12. And then the final one, which we've already worked with, is continuous compounding, which is that.
Continuous is what, every year or every 4 years?
Continuous is continuous. In other words, it's not every month, it's not every day, it's not every minute, it's not every second, it's every moment.
So it's basic. That's just a normal log, or the normal exponential function, right?
Yeah.
And not either the KT.
Right. And in fact, actually, I think it's RT with interest rate.
Yeah, is it right?
Okay, so this is annual. So we'll use this equation. What's their question?
We already have the formula. Find the amount after 3 years. Compounded daily.
After 3 years, compounded daily. Okay, then we want to use the other one.
So it's not 1 plus r divided by n to the power of Tn.
Okay, so the principal after 3 years. It's your starting principal times 1 plus, this rate has to be converted to a decimal, so it's 0.056 divided by what?
Divided by
This is daily. Daily content.
364.
365.
Is leap year 366 days then?
Yes.
Okay.
Okay.
365 to the power of 3 times 365.
Uh-huh. Now that might look outrageous. That might look outrageous because we're taking some number to the 1000th power, but look at the number we're taking to that power.
Yeah.
It's going to be something like 1.00001, and we're going to be raising it to the 1000th power. That's still going to be a relatively small number. Can you do this in your calculator? Do you have the TI-84 or do you have the new Inspire CX?
I have the TI.
Okay. This new Inspire is a slick calculator.
Yeah, I know. One
Significantly better.
It's essentially.
Yeah. It's the one the school system's now dictating everybody get, at least everybody in the lower grades. They probably aren't for higher grades.
Well, it's like the number I got was 4.
What'd you get?
I got 4.
Multiplied by 12,000?
Yeah.
What number did you get?
I got 4,382,016.
So, does that make sense?
Yeah. Did I plug it in right though?
No, it doesn't really make sense. If you invested 12,000 and took it down to the bank, no way it's going to turn into 4 million in 3 years. Okay? So, here, let's do this on Wolfram Alpha. That's the kind of ballpark check that you want to do on these things. Does it make sense? And it didn't make sense there. I wish it did. It'd be awful nice. Let's just do this part here. So that is 1 quantity, 1 plus 0.056 divided by 365, all raised to the power of 3 times 365. And then we're going to multiply this number. Notice what that number is, 1.18.
Mm-hmm.
So I'm going to multiply that by 10,000. 12,000.
12? Okay.
So our answer is 14,195. Let's make sure I wrote it right. Yeah. So 14,195. What did you get? You got 4 million? Okay.
Okay, I actually got it, because I didn't put parentheses around 3 times 260.
Yeah. I tell you what, that's the beauty of the new Inspire calculator, is you put in numbers this way here. You don't put in numbers. You don't put in numbers like this. So you don't have to worry as much about parentheses. And it's much easier, much less likely to make a mistake on that newer calculator.
Yeah, like when I used to put integrals onto that calculator, they had like the format for it already.
Oh, it's beautiful. It's beautiful. In fact, it's a little scary. As a math tutor, I'm asking myself, who has to do anything by hand anymore? That thing will do everything for you. It'll factor a number for you. Maybe the TI-84 will also, but I've never used it for that. But it'll factor in equations. It'll find greatest common multiple, least common factor. I can't think of a mathematical process that you actually have to do by hand anymore.
Really?
Well, I couldn't think of one when I was looking at this calculator. I just got mine a couple days ago, and so I've been kind of playing with it. But it sure looks like they cover just about everything.
Yeah, for Boulder, all the way up through Calculus 3, we're not allowed to have anything other than a scientific calculator on a test.
Huh?
They think they're cheating.
Wow.
Yeah, because that's why you don't have to do anything by hand. And so
yeah.
They don't want
well, it's good to be able to do those by hand. In other words, I really think that a lot would be lost if a person grew up doing everything on a calculator. I'm not sure why, but I just think that it would be very, very difficult to grasp the word problems of calculus without having mastered the techniques. Maybe it could be done. I don't know. I guess time will tell. We'll see in 20 years. We'll either all be idiots dependent on machines, or I'm not sure what the alternative is, but
yeah.
I'm afraid we might all be idiots depending on machines in 100 years.
All right, let me grab this practice.
Okay.
This practice test is kind of hard in the class today. So these are kind of long problems.
It's all right.
How do you, should I just set the same to you, or can you see the picture on your phone?
Can you read them? I can on my phone, but if you can send them to my email, I can pull them up on our screen.
All right. How could I get it to my email from my phone to you?
Just if you take a picture with your phone, you can send it directly to my email from your phone. You don't have to go through your computer.
What's your email?
I'll write it. @gmail.
Gmail.com.
Mm-hmm. Let me pull up my And then actually the next time you go to send me a picture, it'll be a lot easier. You won't even have to type it out. You type the first two letters and it'll remember it. I guess.
Yeah.
You have a Droid system or an Apple?
I have the iPhone, yeah.
Okay. Well, I don't know how
Did
they
you get
work.
it?
Yes, I did.
So I'd say number one, I feel like is going to be on the test for sure. Like a
Okay.
variant of it.
Uh-huh. Okay, so these are optimization problems. So here's the river. 3 equal rectangular areas. And he has 5,600 of fencing. 5,600 feet of fencing. This is a classic calculus problem. Is this a calculus problem? Or is this
Yeah, I'm pretty
a
sure.
pre-calc? Okay, yeah, I just wasn't sure.
Oh, no, this is pre-calc, yeah.
This is a pre-calc problem. Okay.
Yeah.
Well, I think we can solve it without calculus, but let's go through it. If we put some dimensions on this, they want to know what are the dimensions of this area. Well, let's call this X, let's call this Y, which makes that Y and that Y also, and this X. So what's the first equation I can write?
I would think P equals 2x plus 3y. Possibly.
Yeah, and P is 5,600, so I can say 5,600 is equal to 2x plus 3y.
So you wouldn't count it as y being 1. You'd count it as 3 separate.
Yeah, I could have made y the whole length, and then, but it doesn't really matter.
Okay.
Okay, it doesn't matter at all. So, what are the dimensions of the maximum area that the farmer can, we want to maximize area. So what is area?
Well, it would be A equals x times y, but you're not fencing off the river part, so.
The area is still the same. The area is still that times the width.
So does A equals x times y?
Times 3y. If we're going to
3y.
use 3y, if we're going to use y to mean this, then we have to stick with it.
Okay.
I could have made y the whole thing, but let's use it this way. It'll give us the same answer. So area equals 3xy. Okay. Now, the reason this isn't a calculus problem is because we can do it with pre-calc. If area equals 3xy, and I can solve x, substitute it, let's solve this equation for y. So y equals 5,600 minus 2x, all divided by 3. And now I'm going to substitute that in for this function here. So 3x times 5,600 minus 2x all over 3. So here is the equation for area. Notice that that's going to be a quadratic because we have an x times an x. So let me could have done this a little easier, huh? Let me do this for starters. So now we have a quadratic. There's our area of our corral, or whatever you want to call it. How do I find the maximum? If I have a quadratic, I know a quadratic plots like a parabola upside down, right? Because there's a negative sign in front of the x squared.
Yeah.
So how do I find this on a scale? I need the y measurement of that maximum.
Plug 0 in for x?
No, because 0 is going to give you this point here. How do you find the vertex? How do you find the vertex of a quadratic?
Like negative b over 2a?
Yep.
Oh.
That's
so when you use negative b over 2a and b over 2, negative b over 2 squared.
Well,
you know?
b is what here?
5600.
Okay, so it's negative 5600 over 2a. A is negative 2, so that's negative 4. So that becomes 1600, a positive. So this maximum area occurs when x is 1600. This amount right here is 1600. Now, what is the area? Well, we plug in 1600 back into our area equation to find this value. So 5600 times 1600 minus 2 times 1600 squared. That's going to be y. That'll be the area of the corral when x is 1600.
So I got 3,840,000. Maybe I put that in wrong.
No, that could be right, because you're multiplying 1600 times 3y's, so a number over 1,000,000 is appropriate.
Okay, so when do you use negative b over 2a for vertex and then negative b over 2 squared for completing the square?
I'm not sure what negative b over 2 squared is. I'm not familiar with that. To complete
Well, what about
the
when
square,
completing the square?
when you're completing the square, you just take half of the b. In other words, if I have something like this, let me use 6x plus 11. Okay? There's a completing the square problem that doesn't factor nicely. So I'm going to complete the square of it. So I'm going to add, I'm going to take half of that and square it.
Yeah, so b over 2 squared. That's what I was talking about.
How is that b over 2 squared? Half of this is 3. Square it is 9. So where does the over 2 squared come from?
No, like in parentheses b over 2, and then outside the parentheses.
Okay. I got you now.
Yeah, my bad.
No, that's all right. I wasn't understanding it. Okay, so by adding 9 here, I have to subtract 9 to balance it out. So now I can represent this as x plus 3 quantity squared.
Okay.
Plus 2. So that's completing the square. As far as the vertex goes, the only time you're going to find the vertex is if you have a quadratic. So it's important to realize that the area of this corral is a quadratic function, because it's going to be x times y, and y is a function of x. So you're going to have x times some function of x. So you end up with this quadratic. And once you know that the area is a quadratic, you find the peak, the vertex, by using minus b over 2a. You could also complete the square and put it in vertex format. And then that would tell you what the value was. The only problem with b over 2a is it only gives you the x-coordinate of the vertex. So you have to take whatever you get and plug it back into the formula to figure out what the actual area is going to be when x is 1600.
Mm-hmm.
But the reason this is a pre-calculus problem is because it's a quadratic. We know how to solve for the vertex in pre-calculus. If this was a cubic, in other words, if our final function had an x to the 3 in it, now the only way to find the maximum of that is with calculus. You have to take the derivative and set it equal to 0 and solve it. So in a way, this is a calculus optimization problem, but it's one that can be done without calculus because it is a quadratic.
All right. So this next one, yes, what is this one? It says sketch the graph. Number 2. Sorry.
Right.
Number 2 and 3. If we can do those really quickly.
Okay. It's important to know what the graph of the elementary function looks like. Once we know what the graph of the elementary function looks like, then we can graph the function that's translated. What kind of translation is this?
Looks like, would that be up or down or left or right for it?
Well, the negative sign is a reflection across the x-axis. And the 4, in other words, I really want to write this, if I want to know what it is, it's minus log x plus 4.
Plus 4.
So the plus 4
then it would be moved left there.
A vertical shift.
Oh,
vertical. If it was log of x minus 4, then that would be move right 4.
Okay.
Okay? So it
So
depends
it's reflected
on
and moved up.
Yeah. So first of all, let's draw the log function. Well, most log functions all look like this. I can't tell the difference between log base 2, log base 10, log base e. They all go through this point, 1, comma 0.
Yes.
So if I want the negative log x plus 4, I do my reflection first.
Okay.
So the reflection looks like this. It's got to go through that same point. So there's the graph of y equals minus log x. So now we need to move this up 4 such that it goes through this point.
Alright, so basically what I need to know from now is that the normal graph of a log of x is like, just goes through the point 1, comma 0 like that?
Yeah, and it's asymptotic with the x-axis or the y-axis also.
Yeah.
Okay, and they do ask that. So let's look at the domain. Let's look at the domain of the first one. Oh,
So
they only want the domain of the transformed functions. So what's the domain? We're looking at this one here. What's that domain?
Yeah. I would say maybe 1 comma infinity? Or would it be 0 comma infinity?
It's parentheses 0 comma infinity.
0.
Parentheses because it cannot be 0. It's not a bracket. In other words, it's different than the domain of this. If I look at the domain of this, it's bracket 0 comma infinity.
Yeah.
But for log functions, you can't even take the log of 0. So x cannot be 0. It has to be bigger than 0. Okay.
So then the range, I'm guessing.
Before we look at that, let's look at our graph. Notice that you could have read the domain off the graph. Right?
Mm-hmm.
In other words, the domain is whatever the x-axis. If we look at this function, it does not exist to the left of the 0 point. Everything is to the right of 0, and that's where we get the domain has to be from 0 to infinity. What's the range?
And negative infinity to infinity.
Yep. Now, this plus 4 doesn't affect anything on domain and range. You see why?
Yeah.
Because this dotted line is the one that I graphed. That's
yeah,
our y.
It's only moving vertically. It's not moving horizontally.
Right, and it keeps going and is still asymptotic with x equals 0, the line x equals 0.
All right, so what about the graph of 2 to the x? And then 2 to the 3.
Okay. This is the inverse of the log function. Notice the log function looked like this. That's a perfect reflection about the line y equal x. So if you want exponential graphs, they're just inverses of log graphs. And yes, it goes through the point 0, 1, every one of them. Whether it's y equals 2 to the x or y equals 10 to the x, it's going to go through this point.
So I'm guessing then 2 to the 3 minus x would be reflected with a 3?
No. If I wanted a vertical shift, I would do this. That would be the vertical shift. If I wanted a vertical stretch, I would stick the 3 out in front, like that. If, in this case, what I'm actually plotting, if I say f of x is equal to 2 to the x, well, what is this? That's f of 3 minus x, which would be 2 to the 3 minus x. So, sketching its graph. The other way I can write this, instead of 2, I'll call this y, because this is the transformed one. Instead of calling it 2 to the 3 minus x, I'm going to call it 2 to the minus x minus 3.
That's nice.
Now, this minus is a reflection about the y-axis.
So when the negative's in the power.
Yeah, when the negative is in the function, inside the function, it's a reflection about the y-axis. If the negative is outside the function like that, it's a reflection about the x-axis. So this negative, first thing you do is reflect about the y-axis. Next thing you do is do a horizontal translation to the right of 3 units. So let's look at our graph. And then we check it to make sure that we did it right. Okay, so the reflection about the y-axis looks like this. And then I said we need to move it right by 3 units. So there's our new point that it has to go through, which is 0, that's 3, 1. So our new graph does that. Now, just to make sure that we got this graph right, let's plug in this point and see if we really do get 1 when x is equal to 3. here's the function, y equal 2 to the 3 minus x. So I'm saying that when x is 3, y has to be 1, is it?
When x is 3, y is 1. Yeah.
2 to the 0th power is 1.
Yeah.
What that tells me is I did everything correctly. In other words, I reflected it properly and I shifted it in the right direction. Had I shifted it in the wrong direction over to here, then this wouldn't be true. I would know I would be in the wrong direction because when I plug in a minus 3 for x, I get 2 to the 6th.
So, yeah.
So checking to make sure you've done it correctly is extremely important on this because you saw how iffy this was. In other words, I had to take 2 to the 3 minus x and change it to a minus x minus 3. Are you hearing me okay? I'm having a little hard time hearing you, Mike.
Yeah, I think it's my computer microphone.
Okay.
Yeah.
So this seems to be the correct, and then we know how to graph that. What's the domain, range, intercepts, and asymptotes of the new function?
The domain, I'm going to say negative infinity to infinity.
Good. Just looking at the graph, you can see that.
For range, it's like in parentheses 0, infinity.
Good. Hold on a moment. Yeah. Yeah, y can never be 0, but y can get very, very small. If x is a billion, you got 1 over 2 to the billionth power. That's a very tiny number. So it is going to approach the x-axis, even the translated reflected version.
Okay.
So you got the right domain, you got the right range. What's the intercept?
Okay.
There's
The
only
y-intercept
is what?
0,
No. We don't know what this number is yet. We haven't figured it out. So our function is y equal 2 to the 3 minus x, and we want to know what's the y-intercept. What's x when we're on the y-intercept?
0.
Okay, so what's the y-intercept?
3 minus 0, 2, 3, 8.
So that point is 0, 8. And that's the only intercept. It doesn't cross the x-axis ever, so it only crosses the y-intercept. And the asymptote, how would you define the asymptote? And what kind is it?
I'd say a horizontal at y equals 0.
Very good.
And that's it.
Uh-huh. Want to look at number 4 briefly?
Number 4, I know how to find the intercepts. I did this one in class. The only thing I was confused on is right here. I found the y. Well,
First of all, I know what the denominator looks like.
Yeah.
I mean, it looks like x plus 1 times x minus 2 because of these two vertical asymptotes.
Yeah.
I also know that because the horizontal asymptote is at 1, there must be an x squared up there.
Mm-hmm. Oh, what is top heavy again? Like, because I know, like, the leading coefficients. If the top is bigger.
Right. If they're the same power, If it's
and
top
divide
heavy, you have to divide it out and deal with whatever you get. But if it's equal, as it would be here, it's the ratio of the coefficients.
Yeah. But no, I thought if it was top, isn't it y equals 0 or y is undefined or something?
If it's bottom heavy, it's y equals 0. In other words, if I had this,
So yeah, then top heavy means it's undefined.
no, actually it doesn't mean undefined, because you can have oblique asymptotes. If you have x cubed divided by x squared minus 3, I do this division, and I end up with an oblique asymptote that is very critical to drawing the curve. So top heavy means something. It's probably beyond what you've gotten to at this point.
Okay. So the x-intercept is a y, or x plus 2.
Well, let's see. What do I know about this curve? I know a number of points on it. I know that point. I know this point. So the question is,
Because I have the answer. It's x plus 2 squared on top.
okay, that's what I wasn't sure how to get that top. How do we get that? I know that
See,
it's
that's what I was confused on.
Ah,
I was just plugging into my calculator.
yeah, I know how to get it. I know how to get it. It's x minus h squared on top, and that's equal to y. And so,
Well, see, how do you know it's squared though on top?
because of the horizontal asymptote? Yeah. In other words, we have to have, by definition, we have to have an x squared term on top, because I know I have an x squared term on the bottom.
Okay.
Okay? So if I know this is the form of the equation, then I can substitute 0 for x and solve this. And what do I get? I get x squared over minus 2. Oh, excuse me. If I substitute 0 for x, I get h squared over minus 2, which means h is equal, I know y is 0. Hold on, I did this all wrong. Hold on. Okay,
So
I need to
the
solve.
top has to do with the x-intercept, doesn't it?
Right. In other words, if I know y is 0 when x is minus 2, right? So I can make y 0. I'm going to make x minus 2. So I have minus 2 minus h squared all over minus 1 times minus 4. Now if I solve that for h, I'm going to get 2.
So that's how you get x plus 2 squared.
Yeah. In other words, multiply both sides. The numerator has to be 0. So the only numerator that's 0 is an h of minus 2. So that I'll have minus 2 minus a minus 2. That's equal to 0. And your numerator has to be 0 if y is 0. So that's how we get the x minus 2 squared over x minus 1 times x plus 3. Or x
I feel like you
plus.
don't have to do that substitution because when you're finding the x's of a polynomial, you just set the top equal to 0.
Right.
The only x-intercept we have is negative 2, so it would be x plus 2 squared.
Right. You're right. I just needed to set this top equal to 0, and h comes out to be negative 2 that way.
But negative 2 is not right. X minus 2 squared.
Yeah, but if you'll notice the way I set it up, I had x minus h So when h came out to be -2, which it did, it made my function x plus 2 quantity squared over x plus 1 times x minus 2. And I don't need this point over here. I'm not sure why they gave it to us. The only point I need is this one right here. All right. I got to run, Mike. I got another appointment. But good luck on your test in 25 minutes. Is it an online test?
No, it's not.
No? All right. Well, you better get there then.
All right, thanks a lot.
Okay. Talk to you
Just
later.
tell my mom, she said.
What's that?
My mom just said tell her.
Okay.
Send her the bill.
Okay. Yeah, that's what I've been doing. All right.
Thank you.
Talk to you later. Bye-bye.